Good day, students. Shoke Emmanuel here. Today, I want us to look at this topic, at least in a considerable detail, as well as in a certain defined circumstances. It's a topic where I do not think I'll be able to put it down to anything else higher than to say, this is where students sometimes, and more often than not, fail to refuse to smell a dead body. It's called optimization, rates of change, and I want us to look at it together, at least in the easiest, best. So, we do have types of rate of change. So, the word rate of change simply means the gradient. But up to this point, we know that the gradient, we have two types. We have, in fact, different types of gradient. We can have the average gradient between 2 points. Even in calculus, we're still going to maintain and contend that particular view, all right? We also have a gradient at a particular point. That's where we derive a function and we replace that particular x value into the function. So in calculus motion, we are going to define that as instantaneous rate of change. So now let's look at the average gradient first. You're going to be given a function, and we say that x is going to be in between, maybe at a point, and x is equals to maybe a point B. You need to find f of b minus f of a. You divide this. Let's say this was x1, x2. So you're going to have x2 minus x1. That will have been what? That will have been the average gradient. Same thing with calculus, but now we're going to use what? The average rate of change. Cool. We also have the gradient at a point, which is instantaneous rate of change. So if you have a function and you also have a point, x is equals, let's say maybe it's equal to a, you want to find the gradient of this. You're going to find f prime first. You derive it, that function, in terms of x. Now you say f prime at a, this particular point there, is going to give you guys the gradient. That gradient is called in calculus the rate of change. Okay. But now, as far as calculus of motion is concerned, we are going to also invite some concept in there. We are going to have a function s of t, which is going to be given as at squared plus bt plus c. That is quadratic, and then that is your cubic polynomial. But it's a function of t this time around, where t can be time and s can be maybe displacement or a distance or a height of a tree. Now, let's see. We are saying that st represents the equation of motion, which can be what? A height, distance, displacement, of which in exam we're going to tell you as to what does st represent. It can be an object of a moving particle. Number two, we have the s prime at that particular point t. The s prime simply means the rate of change, which is the gradient. But we are going to use velocity or a speed, okay, at a time. Now, the second derivative is going to be the acceleration. So how do you know that this is the acceleration? They will then say, find the maximum rate of change. That means you're going to derive the rate of change, which is the speed. So when you derive the second time, we call that acceleration. Okay, that is in calculus. So I have plus or minus few examples that I've compiled here, and I want us to do them together. Now, the first one, they say, during an experiment, the concentration of glucose in the human body is given by MT, which is going to differ according to the formula. The formula is given by MT, which is MT is equals to 4,8 minus 0,3t squared. That is the formula. Remember, I said we can use S of t. We can even use C of t. Sometimes they will use C of t. Okay, it's a function of t. You don't need to really stress yourself there. So they say find the average rate of change of concentration between the point t and 1. So they want the average there. That means you have what? You have both T1 and T2. I will then say to myself, let me find M of 2 first, and that is going to be 4,8 minus 0,3 multiplied by 2. This is going to give me something. Let's do it together. 4,8 minus 0,3 into 2. Don't forget to put a square there. We need to square that thing, and then this gives us 3,6. Now we need to find M of 1. So M of 1 simply means in this equation we're going to plug 1 now. So that is 4,8 minus 0,3 into 1. And then if we do that, I'm just going to replace that 2 there with 1. It gives me 4,5. So that is C,5. In fact, because of space, allow me to then remove this because I don't necessarily need it. It's given there. So I'm just going to put this one here. Maybe give it its own color like that. So now I want to find the average gradient, which is going to be M2 minus, M of 2 minus M of 1. We divide, this is the average. That is going to be 2 minus 1. And then this gives us M2, that was 3,6. We divide it, we forgot to subtract, minus 4,5. Divide this by 1. So if we do that on our calculator, let's see what we get. 4,5 over 1. So this is going to give us negative 0,9. All right, that is the gradient. Now they say determine, this is the average gradient. Okay, now determine the rate of change of the concentration when T is equals to 3. Again, it's not that bad. Remember I said the average rate of change simply means the first derivative. So if I were you, I would then derive it to then say M prime at T. That is going to give us what? So it'll give us, that's a constant, so it's 0. So if we say 0,3 multiplied by 2, we are getting 0,6, but it's negative now. Negative 0,6 because of that negative in front of 0,3. So this is negative 0,6 T. That is the equation of what? Of the velocity, or the equation of the rate of change, which is the speed or velocity itself. But now they say when T is 3, that means you're going to have M prime of what? Of 3. This is the gradient at a point, or the rate of change at a point. And that gives us negative 0,6 into 3. Let me put that 3 properly. So this, if you check it on the calculator, it's going to give you negative 1,8. Now, they say interpret the answer obtained in B. So we find F prime at a point to be negative. What does it mean? In calculus, it means that the glucose, that concentration of glucose was decreasing, because you will remember that F prime at X, this means increasing. And then F prime at X, this mean, less than 0, this means decreasing. So our derivative here was less than 0. That means it was what? It was decreasing. So let's interpret now. We are going to say that M prime of 3, which is equal to negative 1,8, that is less than 0. So in calculus, because we're dealing with the concentration of glucose in the human body was decreasing. So we then say that the concentration of glucose was decreasing. Okay, the most important thing was to tell us that the glucose of that thing was decreasing. Okay, this was key, decreasing. Okay, that's how you're going to interpret that. Now, the next question, they say, consider a moving particle along a horizontal line. The particle's position function is given by this one. That is given. It's a cubic stuff right there. They say t is measured in seconds. Let's see how we're going to deal with this. They say determine the velocity function of the particle. Remember, velocity means what? The first derivative or the rate of change. So if they say determine the rate of change function, they want you guys to find s prime at t. That is the speed, the velocity, or the rate of change. So now, if you differentiate this in a sense of justice, you're going to get 6t squared minus 6t and then minus 12. That's what you get. You derive this, you get 6t squared minus 6t minus 12. Now, the next question, they say find the acceleration function of the particle. That means you're going to derive this for the second time. So if you do that, we're going to get s double prime at t. That is going to be now 12t minus 6. That is what we get. It's the second derivative. Cool. The next question, they say calculate the speed of the car at what? At t seconds. So remember that the speed of the car is s prime at t. That is the speed. Speed, velocity is the same thing. So you are going to say that was 6t squared minus 6t minus 12. So I'm going to have 6t squared minus 6t minus 12. All right. But now they want you guys to find at t. So you're going to have s prime at t. That is going to be 6 into, let's just put a 5 there. Let's put a 5 there. That means we're going to put 5. We square this, minus 6 into 5 minus 12. That is going to equals to, I can always type it on my calculator. So 6 into 5 squared minus 6 into 5 minus 12. This gives me 108. So this is the speed. Speed is measured in meters per second. Right. That is in meters per second. That's how you guys are going to pen this one down. All right. If you don't want to use this, you can say it's meters per second, like that. If you are doing physics, you will get that particular notation. That's how you're going to deal with this. I don't think it was bad. A recap, velocity is the speed function. So even if they say determine the rate of change function, you still derive that. They say find the velocity function, you derive that. They say find the speed function, that is the function there. The acceleration, you derive the speed, or you derive the velocity, or you derive the rate of change. Simple. Now, the speed when t is 5, that means you're going to use the speed equation. That is the first derivative. You plug that 5 there, and then you're going to get that one. Simple. The next question, they say that the displacement in meters of a car, t, is of a t seconds after going through a traffic is given by the formula. So there is the speed, okay, it's the displacement, and then it's moving in t second. They say determine the car's initial velocity. So initial means 0. But do we have the velocity function? No. Let's get the velocity function. So we're going to derive the displacement, which gives us 10 minus t, because 0.5 times 2 is 1. And then they want the initial velocity. That means it's going to be s prime at 0. Initial means 0. So t is equal to 0. Okay. That is the initial. Unless if they tell you. But in this case, we're going to use 0 because they didn't tell us. That is equals to 10 minus 0. And then this gives us 10. That is the initial velocity. There. All right. And that is in meters per second. That is the velocity there. and then calculate the maximum the car's maximum displacement. What is your displacement? You are given as t is equals to 10t minus 0.5 t squared. They want you guys to find the maximum displacement of this. What can you do? That looks like it's a quadratic. So you can use t is equals to minus b over 2a. You get your t and then you plug it back to the function. But that will be for grade 11 students. For grade 12, we advise that you guys use calculus of motions. That is to derive the maximum. So you then say that s prime at t, that must be equal to 0 because that's where you're going to get the maximum. Think about this as a quadratic stuff. That is the maximum point we're talking about. So let's find it. We then say to ourselves, if we derive this, we get t, we get 10 minus t is equal to 0. Therefore, t is equals to 10. They want the maximum, the car's maximum speed when time is 10, at 10 seconds. So we then say to ourselves, we need to find s of 10. That will be 10 into 10 minus 0.5 into 10 squared. So that is possibly 100 minus 100 divided by 2. I think this is 100 squared. 10 squared is 100. Multiply by 0.5. So we get a 50 there. And then we get 50, I presuppose, but it's a displacement in meters. So this should be 50 meters, like that. That's what we get. Now, they say calculate the speed of the particle at a time t. So, do you have the speed equation? Let's check. It's the first derivative. You need to have it. So, s prime at t, that is going to be equals to, it was 10 minus t. My pen is running out. So there was 10 minus t. But what is t? T is 5 seconds. So therefore, we have s prime at 5 seconds, which will be 10 minus 5. We substitute 5 where there is t. And then we get 5. It's a speed. So that is meters per second. That's what we get there by physics. So I don't think this is really too difficult. Let us do the last question and then we're done for this series. They say an object is moving vertical upwards from the ground and its movement is described by the equation. The equation is 112t minus 16t squared, where s is the distance from the starting point in meters and t is in seconds. Determine the initial velocity. So you see, again, they're talking about the velocity. So what do you then do? You see s prime at t, that is going to be equals to, you derive it. So it's 112 minus, this should be 32t. I presuppose that should be the derivative. But now they say determine the initial velocity. So it means at t is equals to 0. If we do that nicely, we get s prime at 0. That is going to be 12 minus, 1112 minus 32 into 0. And then this leaves us possibly with 1112, and it's a speed. So that is meters per second. It's a velocity. Okay. Now, they say determine its initial velocity after 3 seconds. That is the velocity equation. You then say to yourself, that s prime of t, we had 112 minus 32t, but t now is in seconds, 3 seconds. So we get s prime at t, that would be 112 minus 32 into 3. And then on the calculator, we should be able to calculate this properly. And then this gives us 16. This will be 16 meters per second. That's what we get there. Now, they say calculate the maximum. It's a matter of using calculator. Okay. Carefully calculate the maximum height the object reaches. the maximum height. So you have the object, they want you guys to find the maximum height of this. So the maximum height happens when the first derivative with respect to t is 0. Okay, so we got 1, 1, 2 minus 32, t is equal to 0, and then we solve for t. So if we solve for t, in the easiest best, this looks like it's a very simple equation. So we say 112 divided by 32, and then we get 3,5. So this is 3,5 seconds. All right, so we want the maximum height at t. But t is what? T is 3,5. So this becomes s of 3,5. You plug it into the equation. It was 112. So this is 112 into 3,5, and then minus 16 into 3,5. We square this. It was 16t squared. So we just need to use our calculator wisely. And if we do that, we get 196 meters, because that is the height. We get 196 meters. Okay. So now, the next question, when will it be more than 96 meters above the ground? So remember, you have ST. That is 112t minus 16t squared. When will this be more than? More than means greater than, above the ground. So we're looking for ST bigger than 96. It's not the velocity, they will have told you. All right, it's not the velocity. So now we say 112t minus 16 t squared bigger than 96. So this takes you back to your inequality in grade possibly 11. And to do this, we will be left with negative 16t squared plus 112t minus 96 bigger than 0. We can divide both sides by 16 because it can get into each side. So you get t squared, you divide by negative 16 there, you get negative 7t, and then here you get a plus 6, and then this should be less than now. You factorize this, you get your critical values, that is t, you get 1, 6, they are both negative to get negative 7. So therefore, you get t is in between 1 and 6. They say when will be more than, so in words, it would be the height is more than 96 between the first and the 6 seconds. So that should be in between the first and the 6 seconds. That's how you will do this particular question. So this was a repetition. I wanted to add more questions, and we are done. Okay, we are done for the rates of change. So sometimes I want you guys to see something here. Okay, this is measurements, and we've done this type of questions in our first part of the series. Now, I want you guys to see something. Let us look at this particular exam, which was written by those who are upgrading this year. The grade 12. I'm going to look exactly on that particular section. So if we go there, let's see what we find. So remember, that is calculus. You drive, you do some first principle there, and then your graphs. I want us to look at this one. They say that the oxygen content in the water T days, so T is in days now, after organic waste was dumped into a lake, can be shown by this equation. Okay, so the time is from it was between 0 to 15 days because T is for days. Now, they say, what was the initial oxygen content in the lake at the time that the organic waste was dumped? So they want what? They want at the initial, okay, the initial oxygen. So it means this is going to be C of 0. And then you have 1 over 1200 into 0 cubed minus 15 into 0 squared plus 1200. And then what do you get? So this is going to be 0. So it's 1000 over 2. So this is going to be 1. Okay, the answer was 1 there. When will the oxygen content be at lowest? So lowest and the highest means the first derivative. So it means you are going to say C prime at t, this must be equal to 0. And then you solve for t. Okay, you solve for t. And to do this, this will have been, it's a constant, so it's 1 over 200 into 3t squared minus 30t, and then that is 0, and then that is equal to possibly 0. Okay, you solve for x. You can divide both sides by let me check. So that is 30t squared. So if you divide both sides by the number, you get 3t squared minus 30t is equal to 0. And then divide both sides by 2. So you get t squared is equals to, so that should be 15. T is equal to 0. Therefore, t will be 0 or t will be equals to 15. Okay. That's what you guys get for this. Now, the next question, they say calculate the value of t for which the rate of change, which is the first derivative of oxygen content, is a maximum. That means you want the value of t for which the first derivative is maximum. Maximum means the derivative. That means now you're going to derive that particular function for the second time. Okay, 0. And then you solve for t. So you derive this one now. And then you get 1 over 1200 into 6t minus 30 is equals to 0. You solve for t. So this becomes 6t minus 30 is equals to 0. Then therefore t might be 5. That's how you will do this 7 marks from those who are upgrading this year. Very straightforward question, and they always ask it. Okay. And then I was going through some document here on calculus. It's this one. You can go and look at it. February 2017. It was question 10. All right. They give you the equation, which is in between 0 and 10. They say determine the number of molecules of the drug in the bloodstream 3 hours after the drug was taken. So you take 3 and you plug it there. Now, they say determine the rate. So this is the first derivative, the rate at which the number of molecules of the drug in the bloodstream is exactly at 2. So they wanted to find what? So this is, the first one was m of what? Of 3. And then the second one is, it's m prime at 2 there. It's very much important. Now, the second one, how many hours after taking the drug will the rate, you see now, they're talking about the first derivative, at which the number of molecules of the drug in the bloodstream is changing, be maximum. So you drive that particular m for the second time now. You drive this for the second time, and then you solve for t. You get that 8 marks. I hope you understand what I was doing here. Thank you so much for watching.